This is the full worked solutions to Assignment 6A. Not Assignment 1, sorry, Assignment 6A. Okay, question 1, find this integral. How do we do it? Well, we recognize that we've got this cosine 2x down the bottom line. That's not going to be very helpful to us. So we change this to be the integral of the square root of 1 plus, instead of cosine 2x, we change this to 2 cosine squared x minus 1. And by doing this, we have eliminated the 1. So this is just the integral of 1 over the square root of 2 cosine squared x dx. So that gives us 1 over root 2 at the front from this 2 here. Square root of cosine squared, we're going to get 1 over cosine, but that just means the square root of secant x dx. And we already have a way to integrate secant from our MF15, so we get 1 over root 2 ln secant x plus tangent x plus our arbitrary constant of integration. So that is question 1, 1a rather. So what about 1b? Well, 1b, we've got this. We can't do this as is, so we need to use by parts. So we let u equal to ln x, therefore du by dx would be 1 over x. We let dv by dx equal to x squared, and therefore v is 1/3 x cubed. So using by parts, this then becomes, so this would be our dv dx times u. So we need uv minus, and then swap them the other way around. So uv would be 1/3 x cubed ln x minus the integral of, and then swap them around, 1/3 x cubed 1 over x dx. So this is of course going to be a third x squared. This gives us 1/3 x cubed ln x minus 1 over 9 x cubed plus our constant of integration. So that is 1b. What about 1c? So to do this one, the first thing we want to do is separate out our fraction. So we use partial fractions, and what do we find? So we let 2x plus 1 over x minus 2, 1 plus x squared, equal to a over x minus 2 plus, now 1 plus x squared, that is a quadratic term, so I need to have bx plus c up here. 1 plus x squared in the bottom line. Cross multiply, we get 2x plus 1 is equal to a 1 plus x squared plus bx plus c, x take 2. So when x is equal to 2, what do we find? We find that 5 is equal to 5a plus 0. So that means that a is equal to 1. So now that we know a equals to 1, we're going to choose another value of x that will make our life slightly easier. So when x is 0, we get 1 on the left hand side. Then the right hand side, a is 1, so 1 times 1 plus 0, so that's just 1, plus b times 0 is 0, so you get c times minus 2. This of course cancels out, and this tells us that c is going to be 0. So last value, let's choose when x equals to 1. What do we find? So when x is 1, we would get on the right hand side 3 equals to 2. So a, which is 1, 1 plus 1, so 2, plus b, c is 0 of course, and then 1. So that tells us, sorry, not 1, minus 1. So that tells us that b is equal to minus 1. So knowing all of that, what can we say? This means that this can be rewritten, the integral, as the integral of 1 over x minus 2 minus x over 1 plus x squared dx. And this is quite good for us because we know how to integrate 1 over x minus 2. That'll just be ln mod x minus 2. Now, what about this one? Well, the integral, if I had the integral of 2x over 1 plus x squared, that would be easy. I don't have a 2 here though, but I can get it by just putting a half out the front. So this is ln mod x minus 2 minus a half ln 1 plus x squared plus our constant of integration. Note that I don't need modulus signs for the 1 plus x squared because I know that that one will always be positive. Okay, so let's have a look at question 2 then. Write down the constants a and b such that this is true, hence find this. So we can almost do this by guess and check. You see that you've got two x's here, so you need a equals to 2 straight away. That would give you 2x minus 2. You need plus 5, so that means b is equal to 7. And we can verify that 2x minus 1 plus 7 is 2x minus 2 plus 7 is 2x plus 5. So we've checked that this is indeed the right answer. So I'm just going to get rid of that. Now we need to find the integral, this integral here. So how do we do that? Well, that is a bit of a hint, and the hence also gives us a clue. So we're going to split this top line up. This is actually the integral of 2x minus 1 plus 7 each over the denominator. Now, what do you notice? If you look at this function on the bottom line, you see that its derivative would be 2x from the x squared minus 2 from the minus 2x. So this thing here, this term, is in the form f prime of x over f of x. And when we get something in this form, we know how to integrate it. This one is just going to be ln x squared minus 2x plus 5. What about this one? Well, this one we haven't got the derivative on the top line, but we've got a quadratic on the bottom line. This means that I'm going to be looking at writing it as as the sum of two squares, or the difference of two squares, and seeing what I can do. So completing the square, I get x minus 1 squared plus 2 squared dx. Now this is again a familiar form to us. This is the tangent inverse. So we can write this as ln x squared minus 2x plus 5 plus 7 over 2 tangent inverse x minus 1 from this term divided by 2, and then plus our constant of integration. So let's move on a bit ahead to part B. Find the derivative of tangent x squared. So what is d dx of tangent of x squared? Well, differentiate tangent, you get secant squared x squared, and then you have to differentiate x squared, so you get 2x. So your answer is 2x secant squared x squared. So hence find this. That should be a bit of a, the first part should be a bit of a clue to you, and the word hence is another clue. We're going to have to use by parts, and they're hinting at us to integrate the secant squared here. So the integral of x cubed secant squared x squared dx, I'm going to split that up. I'm going to let u, the thing I'm going to differentiate, equal to x squared. I'm going to let dv by dx, the thing I'm going to integrate, equal to x secant squared x squared. So you can see I haven't done a perfect split. I've taken one of these x's and attached it to the secant squared. So if I differentiated x squared, I'd get 2x. If I integrated x secant squared of x, it's almost this, except I need to divide by 2. So I'd get 1/2 tangent x squared. So we know what we're going to get here. We get 1/2 x squared tangent x squared, u times v, minus the integral of 2x times a half tangent x squared. And again, this is another nice one for us to integrate because we've got the function and we've got its derivative on the outside. So tangent of x squared, and we've got the derivative of x squared there. And we also know how to integrate tangent. We just get ln of secant. So this is just going to be a half x squared tangent x squared minus, and I'll bring this half out the front so that I've got 2x tangent x, tangent 2x tangent x squared. That's going to be ln secant x squared plus our constant of integration. Okay, moving on to 2c. So by performing a substitution, I am to find the exact value of this definite integral. So here we go. I have this integral, so the integral from 2 root 2, oh, what's going on there? 2 root 2 to 4 of 1 over x squared minus 4. Let u equal to 1 over x, or rather the other way around, let x equal to 1 over u. Then dx by du is minus u to the minus 2. So this is the same thing as. Now remember, we also need to change the bounds. So this becomes from 1 over 2 root 2 to 1 over 4 of 1 over x is replaced with 1 over u times the square root of 1 over u whole thing squared minus 4 times dx by du. And we've already worked out what dx by du is. That's going to be minus u squared. So this is from 1 over 4 to 1 over 2 root 2 of 1 over u square root 1 over u squared minus 4 times minus 1 over u squared du. Now we can make use of some of these features. This minus sign, for instance, we can use to swap the bounds, because you'll notice that 1 over 4 is actually smaller than 1 over 2 root 2, so I'm going to get rid of the first one there. And so that'll get rid of the minus sign, so this is 1 over 2 root 2, 1 over 4. You'll also notice I've got u squared and 1 over u, so I'm going to get rid of one of them. Going to cancel that with that. So this leaves me with the square root of, oh sorry, that shouldn't be u, that should be, yeah, it wasn't u, it was a 4. Okay, just making clear. So this is 1 minus 4u squared over u squared times 1 over u du. And of course the u squared, I can bring that out of the square root sign. So it will look something like this. And then this and this will cancel. So I just have to integrate from 1 over 4 to 1 over 2 root 2, 1 over the square root of 1 minus, and 4u squared is the same thing as 2u whole thing squared. And we recognize that straight away as the derivative of sine inverse of 2u. Not perfectly though, because it's 2u not u, so we need a half out the front. Again, going from a quarter to 1 over 2 root 2. I hope that you all remember your triangles. So this will give us 1/2 sine inverse of the top one. So that is 1 over root 2 minus sine inverse of 1/2. If you remember your triangles, that shouldn't be too hard. That's 1/2 pi upon 4 minus pi upon 6, and that comes to be pi upon 24.